Chapter 12 is a chapter based on logarithms, and logarithms are inverses of exponents. And so exponential equations, to solve exponential equations, you need logarithms to undo them, just like you need division to undo multiplication, just like you need subtraction to undo addition. So the question begins, I guess, on how do you interpret this log or logarithm? Logarithm base 3 of 27, does it mean? And probably the easiest way to understand what it means is to understand how to translate this. So this log word can be translated the power or exponent. The power you raise and then 3 to get 27. So this logarithm, this quantity, is the power you raise 3 to get 27. So what we're saying looks very strange. 3 to this thing we're trying to figure out what it means for a power equals 27. So if you put the log base 3 of 27 in here, 3 to this power that you can raise 3 to get 27, 3 raised to that power gives you 27. So the question is, do we happen to know what this is? What is the power you raise 3 to get 27? And it's 3 because 3 times 3 times 3 is 27. So this is 3. Now what is the power you raise 3 to get 1/9? Well, it's -2, because 3 to the -2 power is 1 on top of 3 squared, which is 1 on top of 9. So the power you raise 3 to get 1/9 is -2. The power you raise 10 to get 10,000 is 4, because 10 to the 4th equals 10,000. So this is 4. Logarithms are powers. They're exponents, but they're powers that do a job. This exponent, this logarithm, it's an exponent. The job it does is it takes 10 as a base, and then it's the exponent, and then it kicks out 10,000. So this is telling you the job that this exponent does. Now, when there is no base, there's an understood 10. So this log base blank of 0.01 is the same problem as the log base 10 of 0.01. What power do you raise 10 to get 100? And the answer is -2, because 10 to the -2 is 1 on top of 10 squared, which is 1 on top of 100, which is 0.01. The natural log of a number which we will encounter soon, not yet, is the log base e of the number. And e is a number kind of like pi. It's around 2.7, and that's a little different looking. But if you see the natural log, it just means the base, instead of being a 3 or a 10, is an e. So now what I've done is I've taken a quantity that's a logarithm. This is the power you raise a to get b. And I've set it equal to 11 just to have an equation. So this is called a logarithmic equation. And one of the first most basic things you can do with a logarithmic equation is to turn it into an exponential equation. And so this is the power you raise a to get b, and that power is 11. So we're raising a to something. The power we're raising a to get b is 11, so 11 is the power. 11, logarithms are exponents, and this logarithm equals 11, so that's an exponent. And then the result that we're getting is b. So this says a to the 11th power is b. A times itself 11 times is b. For most people, this is a more understandable equation than this. Although, if they were honest, they would say that they really didn't understand this equation very much. For instance, do you know what the graph of this would look like? And the answer is probably not. But going from logarithmic equations to exponential equations is a useful skill. So let's try it one more time. Let's have the log base 10 of 1,000 equals 3. Let's turn this into an equation. This is the base. A logarithm is an exponent, and this logarithm equals 3, so 3 is an exponent on the base, and the net result is 1,000. Remember, this is the power you raise 10 to get 1,000. And we're raising 10 to that power, and so we're getting 1,000. This is the exponential equation. 10 to the third power is 1,000, and you got to understand that it's a much easier equation to look at than this new kind. So in essence, what we're doing on problems like this is we're taking a new kind of equation called a logarithmic equation, and we're learning how to rewrite them in exponential equation form, which is a little easier for us to understand. Here's an equation that's true, that has an exponent in it, and so the question is, first of all, do we understand it's true? If you take the 1/3 power or cube root of 8, you get 2. So this is the cube root of 8 giving you 2, and then you square that 2. 2 times 2 is 4, and so this is a true statement. But can we go the other direction from the previous problem? Can we take an exponential equation and write it with a logarithm? So we're going to have a logarithm, and that logarithm is an exponent, and the exponent in this problem is 2/3, so we're going to probably have 2/3. The thing that goes down below to the right of the word logarithm is the base. Looks like the base is going to be 8. And the result goes right here directly to the right of the logarithm, and the result looks like it's going to be 4. Notice the way you can interpret this is this logarithm, which equals 2/3. This logarithm is the power you would raise 8 to get 4. So we're raising 8 to the power to get 4. So here's a pretty ugly looking equation, and we're asked to solve it. Why would I call it an ugly looking equation? Well, it's got a logarithm in it, so it's a new kind of equation, and it's got a fraction in it, and it's an equation with a logarithm in it, with a fraction in it, and that blows most people's minds, and we're asked to solve it. We're asked to figure out what x is. So one strategy, a beginning strategy, but a pretty good one, is to change this from a logarithmic equation into an exponential equation. So the base is 16, and the power we're raising it to is the logarithm, because logarithms are powers, logarithms are exponents, and this logarithm's 3/4. And then this is the result that you get. So when we change this logarithmic equation into an exponential equation, it turns out to be an equation where x is already by itself. All we have to do is this calculation, and this calculation can most easily be done by taking this 4 in the denominator and thinking of it as a 1/4 power or a 4th root, and only then cubing that result. And the reason I like this is because the 1/4 power of 16, the 4th root of 16 is 2. Because 4 2's multiplied together gives 16. So that tears, the 1/4 power tears the 16 down to 2. And then 2 to the 3rd power builds it up a little bit. So x equals 8 is the solution to this logarithmic equation.